Spider silk is 5 times stronger than steel by weight, and we still can't make it in a factory. Here's why. When we say stronger than steel, we mean tensile strength per gram. A thread of dragline silk beats high-grade steel wire. Pound for pound, it's not even close. But strength alone doesn't tell the full story. Spider silk also stretches up to 40% before snapping. Steel, it deforms permanently and then breaks. That combo, strong and flexible, is almost impossible to engineer. Here's where it gets wild. Inside the spider's abdomen are silk glands filled with liquid protein. These glands connect to tiny external appendages called spinnerets, through which the silk is extruded. The spider is basically a living polymer factory. The liquid protein, called spidroins, is stored at high concentration, but stays dissolved. Then, as it travels down a tiny tapered duct, something incredible happens. Acidity rises, water is pulled out, and the protein snaps into shape. This transformation isn't triggered by air or contact with a surface. It's entirely orchestrated inside the duct itself, driven by a precise cascade of chemical and physical changes. A dropping pH, shifting ion concentrations, and mechanical forces that cause the proteins to rapidly align and lock into a robust, solid fiber before they ever leave the spider's body. The secret ingredient is the protein's structure, complex repeating sequences rich in glycine and alanine that fold into tight crystalline sheets, surrounded by stretchy coils. It's basically a microscopic suspension bridge built into every thread. So why can't we just copy this in a factory? Here's the problem scientists call the concentration paradox. To make silk, you need proteins at super high concentration, but at that density, they immediately clump and solidify in any normal container. The spider sidesteps this by keeping proteins in a special looping structure that hides the sticky parts, until the duct's pH and ion gradients trigger them to unfurl in perfect sequence. It took 380 million years of evolution to nail that trick.